Good morning, class. So today we're looking at equations and inequalities. Now last lesson we looked at quadratic equations, correct? Now we're going to look at, we have done the word problem. I don't think I got through the word problem during our lesson. Okay, you're going to go watch this explanation online. You will get a word problem in the exam. You must, okay, for about 5 marks. Alright, so now today we're going to look at simultaneous equations. There's going to be 2 parts to this lesson. We're going to spend some time on the equations and the simultaneous equations out of exercise 4.7. There's one example here. I'm going to do that one example. I'm going to give you 2 minutes to do it. What's wrong? Why are you talking? Okay, so simultaneous equation, what does it mean to do something simultaneously? Huh? Sorry? Together, or at the same time. Not so. Now, simultaneous equations is to solve more than one equation at the same time. Okay. So, we're reading on page 83. There is an exercise on page 46. There's a little investigation there. Out of exercise 4.6, we're not going to go down that route, okay? So I'm going to explain to you straight. You don't have much lessons before you write your upcoming control test. So a linear equation need not to be restricted to one variable. So what does linear mean? The highest power on x is 1. So if it's not restricted to one unknown, what is the unknown? It's normally x in an equation or y. Okay, so now we're going to have more than one unknown. The only requirement is that all the variables must have the degree 1. So that's linear. We call several linear equations in the same variables a system of linear equations. So more than one linear equation is, we've got 2 or 3 linear equations, it's called a system of equations. That's basically what they're saying here. In general, to solve a system of linear equations, to find the value for the variables that satisfy all the equations simultaneously, which means that at the same time, there must be the same number of equations as there are variables. So if there's 2 variables, how many equations must there be? 2. If there's 4 variables, 4 unknowns, how many equations must there be? 4. There's 1 unknown, how many variables must there be? 1. Okay. I know you guys have done simultaneous equations in grade 9 as well. Not so? Yes. Huh? Who did simultaneous equations last year? You wrote it on it, it came in your exam as well. You did simultaneous equations last year. But okay, if you didn't do it, it's fine. There must be the same number of equations as, right, we said that we shall consider the system of 2 equations in 2 unknowns. Okay, so that basically led into exercise 4.6. Okay. If 2 equations are represented graphically, the point of intersection of the 2 lines, if there is 1, is the solution that satisfies both equations. Okay, remember when we did graphs last year? No? And then there was that one equation, one line going through there, and then there was another one going through here, and then we used to work out this point. Do you remember? You still don't remember, Michael? In front. You did it. Huh? Yes. So why you say no? We did it last year. When we worked out that point, we worked out the point of intersection. Okay? And how did we do that? By using simultaneous equations. Okay? We said the 2 graphs equal to each other. Maybe you didn't know that was called simultaneous equations, but we have done it already. Okay? As before, a system of linear equations can have no solutions. Okay? One unique solution, or definitely many solutions. So this is one solution. They're cutting at one point, not so. Otherwise, if they're talking of no solutions, then if you have those 2 lines which is parallel, would those 2 straight lines ever intersect each other? No. So if you say those 2 graphs equal to each other, we will get a no solution answer. You guys understand? Right. But we'll do more of that when we draw these graphs and things like that. Alright, so then tell me there's no other possibilities. Okay. So now we're going to look at algebraic solution of simultaneous linear equations. Using graphs to solve a system of equations can give approximate answers. Using substitution to solve a system of equations can be tedious and time consuming. Now just going back here quickly. You see that? This is by approximation. Can you see that? So if my graph is not drawn to scale, then I could have distorted values or values that is not true. Can you see that, people? It's approximation values. So the more accurate your graph is, the better the chances of you getting the linear or the point of contact. Okay? Whereas if you do it algebraically, so this is graphically, né? What does graphically mean? By graph. Okay. So if you do it algebraically, you will get the exact value. Okay. System of equations can be solved algebraically. We are going to look at two methods of solving simultaneous linear equations. The method applies to a system of two or more unknowns. There are two ways of doing this. It's by substitution and by elimination. Okay. I'll show you both methods, but I prefer to do the substitution method. Okay. So let's go with the first type, the substitution method. Okay, so write this down. This is the example 1. And this is example 1 on page. Sorry? 85. Alright, example 1, page 85. So as I said, there's two ways of doing it. It's elimination and substitution. I'm going to do the substitution method first. As I said, I'll do both with you so that you can see which one of the two you prefer. Okay? So by substitution, the first thing is we label our equations. Okay? So let's label the equations. So you must write the notes now. No? First you're going to label the equations. This is equation 1. That's of course equation 2. Okay. So the second step is from one of the equations make either x or y the subject of the formula. From one of the equations, now either equation 1 or equation 2. Ne? You either make x or y the subject of the formula. Okay. So if I go to that second step, you see I've labeled my equations, not so? Secondly, I must make either x or y the subject of the formula. So if you look at equation 1, do you think I will make y the subject of the formula? Why not? So I have a 2, you must still divide by 2, you're going to work with the fractions then. Not so? So we normally choose, whichever we make x or y the subject of the formula, we always choose where there's a coefficient of 1 in front of x or y. Okay, so make a note there. Always try and make the whichever subject of the formula you choose, you're always going to try and make it, take the one that has a coefficient of 1. Okay. So from equation 1, you see I'm taking from the equation 1. Then I write from equation 1. If I was going to make x a subject of the equation from equation 2, then I would have written from equation 2. You guys understand? Alright. So what do we say? We're going to make y the subject of the formula. We take that over, x, we take that over. So x is equal to minus 2y plus 5. And this is equation, that is 1. This is equation 2, then this is of course equation 3. The third equation we have. Okay, you guys understand? You understand? Well, what you confused about? Third equation. Sorry? Where is it coming from? Yeah, I didn't wrote here from here, equation 1. From the first equation. It's coming from here. What did I do? I made x the subject of the formula. You understand? So if I had made x the subject of the equation 2, then I would have said x is equal to y minus 1. And this would have been equation 3, and this would have been from equation 2. You understand? But because I took it from equation 1, that is why I've listed from equation 1. Okay? Any other confusion? No. Now we take that equation 3 and you substitute it into equation 2. Okay. I'll tell you now why in equation 2. So the next bullet would be substitute equation 3. Write this down. Amber. You substitute equation 3 into the other equation. Right? The other equation. The reason why you're not going to say equation 2 is because what if I had used equation 2? Then I would have substituted equation 3 into equation 1. You see, we substitute into the other. You see, if I substitute this into equation 1, then you'll get 0 is equal to 0, pure identity. You understand? So you won't be able to solve for x and y in that case. Okay? So, let's go with that. So wherever I now see an x in equation 3, I replace it with negative 2x plus 5. You guys understand? So do the substitution quickly. Okay. What is x? Negative 2x plus 5. So what is going to read now? Negative 2x. Sorry. Negative 2y. Is that why you're going to... You're going to say negative 2y plus 5 minus y is equal to negative 1. Okay. Now, so what do we do thereafter? Solve the first unknown. In this case, it's going to be 1. Solve the first unknown. Okay. So let's solve for y here quickly. We take it 5 over the equal sign. Is minus 2y minus y is equal to negative 1 minus 5. What is minus 2y minus y? Negative 3y is equal to negative. Divide by negative 3 both sides. Y is equal to? Alright, so what do we do from here now? Then you solve for x, yes. But you see, yes, now you're going to substitute. You're going to substitute the unknown into equation 3. Why do you think I'm putting it into equation 3? Because we want to solve for x, and x is already the subject of the formula. Can you see that? If you're going to substitute into equation 1, there was no problem with it. It's just that you had to take it over the equal sign afterwards. Can you see that? Or if you go into equation 2, the same thing. You guys understand? Right. So let's do the substitution. What do we get? So now you're right here, we're going to substitute y is equal to 2 into equation 3. Yes, Michael? Yes. But it's going to go into equation 3. that equation. Okay. So this is something I want you to add here, is that normally what we write here is substitute equation 3 into equation 2. We always write that there. Okay? So add that in there. I'm going to do the sum again with you now, don't worry. So we substitute it into equation 3. What is it now going to read? X is equal to negative 2 times 2 plus 5. What's negative 2 times 2? Negative 4. Negative 4 plus 5? So x is equal to 1. Okay? We leave it like that. So now, let's check here. If x is 1, then y is 2. Let's see what's correct. So if I put, if x is 1 plus 2 times y, which is 2. What's 2 times 2? Plus 1 is 5. So that one works. X is 2, y is 1. 2 minus 1 is? No. X is 1, y is 2. So it's 1 minus 2 is? Negative 1. Can you see it works? Okay? You want to do it again? Alright, let's go a bit quicker. Alright. So here we go. So what do we do first? Label. Equation 1, equation 2. What do we do then? Make x or y the subject of formula. I'm going for, let's go with equation 2. No? So you say from equation 2. What do we have? X is equal to y minus 1. And this is equation 3. So what do we do now? Substitute equation 3 into the other equation, which in this case is the equation 1. The other one is. So what do we write here? We substitute equation 3 into equation 1. Okay? So the equation now reads, wherever I see an x, I replace it with y minus 1. Can you see that? So it will be y minus 1 plus 2y equals 5. Now you're making y the subject of your formula. You take it over, becomes y plus 2y is equal to 5 plus 1. So 3y is equal to 6. So what is y equal to? Divided by 3 both sides. So y is equal to? So what we do now? We substitute y is equal to 2 into equation 3. Why into equation 3? Because already we have x as being the subject of the formula. Not so? So what do I say now? X is equal to 2 minus 1, which is? Okay. Any confusion? Okay. So now we're going to look at the elimination method. Okay, wait. This exercise, in the exercise 4.7, deals only with the substitution method. So I think we're going to introduce the elimination method. You guys are going to get confused. Okay. So now I would like you guys to do exercise 4.7. We're going to do on page 85. We're going to do number A, 1A, C, E, and G. Okay. Yes, sir. I'll stop the video at this point. I know the videos were so long.